Welcome back to A320 Knowledge, your trusted source for Airbus expertise. Today, we're diving into our final tutorial on the overhead panel. The A320 has hundreds of different buttons and switches, and we'll be tackling each of them section by section. In this tutorial, we will be tackling the cargo ventilation, flight control, FMS loading, and maintenance panels. We have the cargo ventilation panel, which ensures proper airflow through the cargo compartments by using an extraction fan. The extraction fan draws air from either the forward or aft cargo compartment and exhausts it overboard, allowing air from the cabin to replace the exhausted air, thereby ventilating the cargo compartments. The aft isolation valve switch controls the isolation valves and the operation of the extraction fan. When set to auto, the inlet and outlet isolation valves open, and the extraction fan runs if no smoke condition is detected in the aft cargo bay. If smoke is detected, the system automatically isolates the compartment. When the switch is placed in the off position, both the inlet and outlet isolation valves, along with the trim air valve, close and the extraction fan stops. If the fault light illuminates, it signals that an isolation valve is not in the correct position, which will trigger an amber light and an ECAM caution, indicating the need for further troubleshooting. Above this is the flight control computer panel, which houses the secondary flight control computers. These computers function similarly to their counterparts on the left-hand side of the panel. Each switch allows pilots to control the individual computers, and in normal operations, all switches are left in the on position, which engages the associated computer and extinguishes any indicator lights. When the switch is set to off, the off light will illuminate white, indicating that the associated flight control computer has been disengaged. If a failure is detected, the fault light will illuminate amber. The fault light also illuminates during the computer's power-up test, which lasts 8 seconds and occurs each time electrical power is applied or after an electrical transient or interruption. The fault light will extinguish once the power-up test is complete or when the switch is set to off. If a failure occurs, pilots can attempt to reset the system by turning the switch off and then on again, which will reset the computer. Above this panel, there is also the third audio control panel, which we will cover in a separate tutorial discussing the pedestal controls. Further up the right-hand side, we have the FMS load panel, a component primarily used by maintenance teams to review and update the aircraft's databases. This panel allows updates to be loaded into the flight management system, including essential data such as the FMS software, nav database, airline modifiable information database, operational program configuration, perf database, and the magnetic variation database. These updates are crucial for ensuring the accuracy and functionality of the aircraft's navigation and operational systems. Lastly, we arrive at the maintenance panel, which contains switches and indicators generally used by ground engineers rather than pilots. One function available to pilots is the CVR headset switch, which allows them to monitor the cockpit voice recorder during system checks through a headphone output. The oxygen timer reset button is another feature available to pilots, though it is typically used by maintenance personnel to reset the control circuit of the passenger oxygen system after a deployment event. When pressed, the passenger system on light goes off, and if the door latch solenoids are energized for more than 30 seconds, the fault light will illuminate in white. Another important function is the service interphone override switch, which controls access to the service interphone system. In the auto position, ground personnel can communicate with the flight crew through the service interphone jacks 10 seconds after landing, provided the aircraft's landing gear is compressed. When placed in the on position, the interphone system remains available for ground crew use regardless of gear status, and the on light will illuminate white. There is also a switch for the avionics compartment lighting, which provides illumination for maintenance access. When set to auto, the lights activate whenever the avionics compartment door is opened. Placing the switch in the on position manually activates the lighting system, ensuring illumination as needed. Additionally, the blue pump override switch, which is normally guarded, can be used to force the blue electric hydraulic pump to operate if the system is in auto mode. When set to on, the pump will run if the ELEC pump push-button switch on the hydraulic panel is also in auto. In the off position, the pump operates based on the automatic logic of the hydraulic system. The hydraulic leak measurement valves, also protected by guards, are designed to isolate hydraulic flow to the flight controls. When set to on, the corresponding electrohydraulic valve opens, ensuring normal hydraulic function. In the off position, the valve closes, shutting off hydraulic supply to the primary flight controls. The APU system test switches allow engineers to check critical fire warning and extinguishing functions. When the test switch is pressed, the system performs a full test of the APU fire detection, auto-extinguishing, and shutdown circuits. If all circuits are operating correctly, the OK light illuminates. However, this test should not be used while the APU is running, as engaging the test will automatically shut it down. The reset button is available to clear any test indications and return the system to normal operation. Lastly, we have the engine FADEC ground power switches, which control how the FADEC system is powered while on the ground. When set to off, the FADEC system is powered by either the aircraft's electrical network or its dedicated FADEC alternator. When set to on, the aircraft's electrical network exclusively supplies the FADEC system, provided the engine fire push-button switch is not pressed, and the FADEC alternator is not supplying the system. This is sometimes used by the flight crew to record engine oil quantities on the ground when the FADEC has become depowered, such as after a single engine taxi or for extended periods on the ground when the engines have been switched off. Our popular A320 tech quizzes are now part of an exclusive newsletter membership designed to provide you with even more value. As a member, you'll receive 4 brand new A320 tech quizzes every month, one each Monday, delivered straight to your inbox. You'll also receive exclusive deep dives into A320 systems, procedures, and techniques that go beyond this YouTube content. And you'll also gain access to bonus content and other surprises to keep your knowledge fresh and up to date. If you're interested, click the link in the description or scan the QR code on screen to sign up today. Thanks for tuning in, and let's take your A320 knowledge to the next level.